here with
Lorenzo. I also work at WebD with Matteo.
Okay, and today we're going to talk about REST API validation on a TypeScript frontend. And let's start with a quick example. Let's pretend that we have our beautiful app that is a Pokédex app. And as many of you probably know, a Pokédex is something that brings you data of Pokemon. And to do so, our application needs to invoke some API, some REST API in this case, that we call getPokemon API. And this API is going to provide us something like this, a JSON with a particular shape. And at day one, our application is fully capable of handling this response, and so is able to display this Ditto Pokemon is happy and everything works. But what if at day two there's a change, a breaking change? Let's see this day two scenario where the API has changed its shape, but our client is still the same, and it ends up to kill the poor Ditto. And we don't want this to happen, and today we're going to find a solution to this. And to do so, let's first of all go through our today's agenda.
Yeah. So basically, we will first understand the data contained in the response, then how to cast it at compile time, how to validate at runtime, choose the right approach between these two, try some code, and then recap everything at the end. So first of all, we should understand the data contained in the response first. The problem here is that REST APIs don't follow a strict protocol, so like SOAP, for example. So breaking changes could still happen in the future. And the response could still differ from the contract we expect. We want to handle these unexpected behaviors of the API. To improve these, both frontend and backend should implement and follow the OpenAPI specification to keep the schemas in sync between the client and the server. You might think the first solution with TypeScript could be cast the type at compile time, either inferring it from the OpenAPI specification or creating it from scratch. So let's take an example, this one. Here we can create an interface called Pokemon, which contains the ID field, among others, which are irrelevant for now. The get Pokemon just below will fetch the Pokemon Ditto API, and we expect it to be a JSON, and in particular a Pokemon with a Pokemon shape. But how are we able to assign it to the data variable? Well, because the type returned by the JSON method of the response is type any,
Yeah.
the giga type.
My favorite type. Yeah. You can solve every problem using any. Yeah.
But we are still unsure what's gonna be at runtime. So we're gonna make it sure that we have the exact response schema by implementing a strong data validation. Therefore, we should handle unexpected errors and provide meaningful feedback to the end user. How can we do this? So what's the real solution here? We can create schemas for our responses using a validation library that we will see later which one. They will both provide types at compile time and validation at runtime. What should we validate, and what these libraries do? We define a specific set of rules for each field containing the response. We expect it to be for each of one of a correct type. Could be string, for example, string, number, boolean, whatever. We could add extra checks, so if they are required or optional, if they are within a valid range for numbers, either negative, positive, etc., or if it's a string, they could match a regular expression. Yeah, and that being said, this whole set of rules makes the defined schema. We should take into consideration some aspects though. We are adding some code at runtime, so that means we're gonna adding some additional processing that could slightly add some performance overhead, especially with large volumes of data. Rules must be written and kept updated and tested, especially to avoid unexpected behaviors, since it's still code we write, we developers. And as the backend evolves, we should keep these rules updated as well. Otherwise, the response will be wrong and fail the validation. This is a quote from Douglas Crockford, one of the fathers of the JavaScript ecosystem, that says, "It is much easier to validate the correctness of data than it is to repair to the consequences of errors." And now we can have some hands-on.
Yeah, it's finally time to write some code. But first of all, let's go through our 3 libraries that we're going to see today. The first one I want to mention is Yup. Is the most commonly used by the community actually, and was firstly designed for JavaScript, and in a second moment has received the TypeScript support. But if you want to use TypeScript, I suggest you to use Zod, as is a TypeScript first schema builder. And finally, if you are using TypeScript and functional programming style, you should go with IOTS, flagged for mature. So we have our response with this particular shape, and we want to make our client stronger and create some validation on this particular JSON. Actually, the data returned by the API is quite a bit longer. We got some unwanted field. Okay, here we have our first schema built with Yup. We can jump on the code. Let me. Okay. Oh, this is impossible to do right now. But I try to see from here. Okay. So how do we use these libraries? Let's say we want to create this schema, and we just need to specify the type of the field that we want to validate every time we're going through this field. For example, here we want to validate an object that has a certain shape. For example, here we have our first field that is abilities. That is an array of object, again with a shape that contains a field. A field is ability, that is again an object. And finally we have a field that is called name, and that is a string and is required. We have also another example of string that is URL, and as you can see, we are applying some extra validation to make sure that it's just not a string, but it's also a URL. So basically, this library is going to apply some regular expression to make sure that this field is a URL, so that maybe later we can show it to the user and make it clickable or stuff like that. Going on, we have a boolean and a slot. One thing that I want to notice here is that Yup wants you to flag every field to be required in case you want it to be required, because by default Yup is going to treat every field as optional. And also here, where's the type Pokemon, there's the way we can generate a field starting from this schema. So I'm trying to show you how it looks like. Okay. So as you can see, we have a quite readable type that has been generated from the schema, and this is something that is going to save you from writing some boilerplate and some extra type that are useful at this point. Useless, I want to say. And for what regards to the implementation here, as you can see, we just need to implement our schema and use the validate method to check the response that we just received from the server. And in case everything is good, we're going to have this validated response back to our client. Otherwise, we can handle the error and show something to the user. And let's move to the next library, that is Zod. It's pretty much the same thing. Okay. The first thing that I want to notice is that every required method is now gone, since Zod is wants it in reverse. So by default, every field is required, and if you want it to be optional, you have, like in the slot field, you have to flag it as optional. And this is because Zod follows something that is inspired by Typescript. So if you want a flag to be optional, you have to flag it with a question mark, for example. Here we have also those URL method to check that is actually a URL. And for what regards the, I can find the mouse cursor. Okay, here it is. Okay, the type that is produced by Zod is a little bit better than the Yop one. And this is because, as we said before, this is a TypeScript first library. And using this kind of schema that is quite simple, actually, we don't see too many differences between the two libraries. But I can assure you that if you are going to handle some complicated objects, Yup is going to struggle with the type generated. And for what regards the implementation, it's pretty much the same. We have a validation method. Let me try to, maybe this one. No, I'm not able to read actually. So, let's move back to the presentation so I can, okay. Finally, we have IOTS. With IOTS, the schema is again something similar to what we just saw. The main difference is that we are using some constants instead of functions of methods. But what, of course, is going to change is the implementation. Since IOTS is something that was meant for functional programming, the data returned by the validation method is going to be an either. So on the left, we're going to have the error, and on the right, we're going to have the result. And so basically, this is what solves our problem that we saw before. I want to show you some tricks. And okay, for example, as Laura said, for numbers here, we can specify, for example, that is, if it is positive, we can check if it is, of course, negative. We can check that is a minimum value, maximum value, and so on. Also for strings, we have some fancy emoji validator. Okay, this is my favorite one. And I also wanted to show you a quick example of how you can turn a simple type that I have created here. It is actually quite simple. It's not anything near to what we saw with Christian before. But by using plugin that is available for VS Code, and I think also for IntelliJ, we can generate a schema by just writing this. And I show you how this should be the one. Okay. And as you can see, it created some schemas from each of the types we just wrote before and created our schema. This is really simple and works with also some complex objects. Only problem is with branded types, but you can still use brands by going, for example, where's the string? Maybe here. This is quite hard. I don't know what I'm doing. Okay. I show you on the other side here. Okay. We can create some branded type also with this method. And so this brings me almost to the conclusions. And so I want to ask Lore, which is the best library of these three?
So it depends. It depends on what? On your coding style, on your project configuration, a lot of things. Personal preference. That being said, YAP, unless you have an existing project with it, it's not recommended anymore for the reason that it doesn't support TypeScript quite well. If you're creating a new project from scratch, a TypeScript one, Zod is the best choice. Unless you have more of a functional programming style, then IOTS is the way to go. That's pretty much it.
Yeah, and if you go with that QR code, you can download this presentation. Here you can find a quick project. Maybe I can show you also the project here, where these three libraries have been implemented. You can so play with them, trying to change the schemas, and also we also attached some useful links where you can find some inspiration, some guidelines on how to use these libraries. Let me show you quickly the. Okay, this is the cited. It's a React.js. It's a stupid app actually. Every button here is going to call the Pokemon API and applying a validation with our three different schema that we just saw. And I can show you how these three libraries actually works and how returns. Here we're going to see the return data. Okay, for example, this is the response that we have after validating it, because the schema we just created is compatible with the response. And I can show you how Zod and IOTS instead are treating data a little bit differently. Zod and IOTS here are just cutting away all those fields that we don't want. And that can be pretty useful in our application in order to avoid to print maybe something that we don't want. But let's see how it works if we are going to, for example, here with job, let's change this. I want to validate this to be, oh no, Boolean, okay. No, what I just, okay. And tada, it broke. But the point is that here I'm able to handle the error. And also, if I want to do some debug, the error also showed me what went wrong. Okay, and this is really useful when we are going to integrate some new APIs, and maybe when there are some changes on APIs. And so it's pretty much it. I don't know, we have still 1 minute. I don't know if you have any question. Yeah. I just send for the microphone.
Okay, thank you for the presentation. I think that is very interesting.
Yeah, thanks.
The question is about the integration in a full stack environment. So,
okay,
I usually write a Swagger and generate the server part.
Yeah.
And so I'm interested in something that convert the Swagger into Zod, I think. Mm-hmm. And the other question is if it expresses the same power of the language of the Swagger one.
Yeah, pretty much. That depends on the plugin you're using to auto-generate the schemas. So, I think most of the fields are supported. Depends on the Swagger or what you are creating. No, because I only use full stack application written entirely in JavaScript or TypeScript, so I didn't use Swagger because Java oriented.
So that's it. That's it. If you want to
There
ask
was
some other question, you
There
can
was
find
another
us.
question from another
I
person.
think that we don't have any time.
Okay.
So thank you again.
Thanks,
You can
everyone.
find us all over here.